Hello and good morning. I be to Professor Dr. Lim Si Chu. So first of all, I want to introduce myself. My name is Hanisa binti Ahmad Safiman with matric number 157188 from group M7A. So in this video, I want to present a VIVA voice presentation for thermal conductivity measurement for poor conductor. List this experiment. Objective for this experiment is to find the thermal conductivity measurement for poor conductor. So the first question is, explain the physical process by which heat flow by conduction through metals in a material. So conduction is the transfer of heat between substances that are in direct contact with each other. The heat flow by conduction through metals in a material can be represented on an atomic scale as an exchange of kinetic energy. The better the conductor, the more rapidly heat will be transferred. Conduction occurs when a substance is heated. So the particles will gain more energy and the vibrating molecules with greater amplitudes collide with their neighboring molecules. As these molecules collide, thermal energy is transferred via conduction to the rest of the material. This then continues and passes the energy from the higher temperature region to the lower temperature region of the substances. The next question is, explain the meaning and the physical impact for the variation in values of A, T minus T prime and L with respect to heat flow H as shown by equation 3. So the equation 3 is H equals to Ka times T minus T prime over L. So from the equation 3 above, H is the rate of heat flow. K is the thermal conductivity coefficient of the observed material. A is the cross-sectional area of the disc. T minus T prime is the temperature difference across the disc, and L is the thickness of conducting surface separating the two temperatures. So, heat flow is directly proportional to the cross-sectional area and the temperature difference, and heat flow is inversely proportional to the thickness. Okay, therefore if the cross-sectional area or the temperature difference is increased, then heat flow will be increased too, since it is directly proportional. Meanwhile, when the thickness of conducting surface increase, then the heat flow will be decreased. When the thickness of conducting surface decrease, then the heat flow will be increased. Thus, a good thermal conductor will have higher K value for thermal conductivity. So the K is the thermal conductivity coefficient. Okay, the next question. Explain the physical process which leads to steady state in a heat conduction experiment. So the physical process which leads to steady state in a heat conduction experiment is when there is no change in reading of thermometer. Steady state in any field means that the properties being measured do not change with time. The system has finished evolving, and now the properties when measured at a point do not change with time, whereas they may or may not change with location. In this state, the rate of heat flow of the metal is the same as the rate of heat released from metal to surrounding. Okay, next question. Explain why temperature at steady state can be derived from the graph of T against 1 over T. So this is the example of graph 1.1. So the temperature at steady state can be derived when the time is very large, which can be approximately to infinity, which T approach infinity. So from the graph, when T is infinity, 1 over T approach 0. The y-intercept is the value of the temperature at steady state. Thus, this illustrated that after several time, the temperature is still the same and does not vary with time. Explain whether instruction to conduct experiment for two different values of electrical power P will produce an expected result for the coefficient of thermal conduction K or otherwise. So, conducting experiment for two different values of electrical power will not produce an expected result for the coefficient of thermal conduction. This is due to the coefficient of thermal conduction that is always constant value for certain material and only depends on the material of the object. It is not dependent on an electrical power supply. Rather, it is dependent on the sort of material it is made of. So in conclusion, changing the power will only affect the heat flows in the material. So that is all from me for my presentation. Thank you.